Buddy, welcome to the weather breakdown. It took me a while to get a new video out, but I was busy creating an automation for my new weather chart. I created a few nice ones, if I may say so myself. I would like to share a little bit with you today to look at what's ahead. But first, let us look at what's going on over Europe right now. It's Sunday, February 3rd, and we're going to look a little bit ahead, like a few days ahead or something. But let's first see what's currently happening over Europe so we get a lay of the land, and then see what's ahead so we can show you guys a little bit what you might expect in the next coming days. Weather does what weather wants, so let's take everything what you see in the far future with a little bit of salt. So let's look a little bit what's happening over Europe. As you can see here, you have a ridge with the ridge axis situated like this. Why is that ridge here? Well, there's an upper level low here, and there's a long jet streak moving like this, creating an anticyclonic circulation like this, leading to a ridge buildup or the extension of the ridge here over Central West Europe. You can see here that there are darker brightness temperatures. Those darker brightness temperatures indicate sinking motion. And sinking motion leads to adiabatic compression. Adiabatic compression leads to drying, leading to the darker brightness temperatures here. So whenever you see darker brightness temperatures on a water vapor imagery, you can synonymously identify it as sinking motion. We have that. Also, if we extend the flow here, you can see that that flow is moving like this around the upper level low situated here. Geopotential height contours are wider here than they are here. So in this region, this means you would have PVA, positive vorticity advection, leading to upward vertical motion, leading to the thunderstorms here. As you can see here, there are thunderstorms happening here as well. There's enough instability there to initiate some air mass thunderstorms around there as well. This jet stream moves like a little bit further. As you can see here, this is closer together than here and then here, meaning that there's a jet maximum here going like this. If you want to know how that works, check a little bit our previous video, our first video actually, where we delved a little bit into how jet streams and jet streaks work. So this is the current situation over Europe. So let's now look a little bit at what's ahead when we delve a little bit into the weather charts and see what we might expect in the future. We've now looked a little bit at what's happening currently over Europe. We're going to now look at our weather charts here to see what we might expect in the future. Also correlate a little bit what we see in the weather charts with what you see on the live map. So that's one thing. Another, again, if you like what I do, please leave a comment in the comment section to say what you liked about it. Also, you potentially say what you didn't like about it. Also, don't forget to subscribe, because we are going to release some new videos in the future, leading to all sorts of material, weather forecasts, such as a little bit this one, more generic meteorological information, and even lectures about how meteorology work in depth. So now that we've covered that, let's look a bit at our weather charts and see what we might expect now, and let's go. As we've already discussed, we were going to look a little bit at our weather charts now, and we're going to correlate a bit what we saw on the weather charts with what we saw there in our live map. What you see here is the mean sea layer pressure and 500 millibar geopotential height in the black contours, mean sea layer pressure in the color fill, as you can see here with the lighter contours indicating pressure. Right. So as you can see here, there's definitely a ridge here with the ridge axis extending like this, as we've already discussed. We've discussed the sinking motion, as was evident into the darker brightness temperatures. This sinking motion leads to a higher pressure here. And as you can see, since the jet is moving like this here, there's a whole anticyclonic circulation moving a little bit like this, leading to the rather extensive high pressure area there. If you now look a little bit further, we will see that that high pressure area starts to move south and southeast while it gets compressed. And as you can see here, the pressure is starting to fall here. So as you will see when we go a little bit further, there's a trough digging southward, more or less here, as you can see here in this position. And if we stop this location here, if you remember our last video, you can see that geopotential height contours are rather tightly spaced here, which means that there's a jet maximum here, and the left exit region of the jet is where you would see pressure falls, leading to a formation of low pressure here. If we go a little bit further, you will see the exact same as this region starts to dig further south. So this region digs a little bit further south, We have the same here. You can see that geopotential height contours here are very tightly coupled together, meaning that there's a jet maximum here with the left exit region here leading to the formation of a low pressure area that you see here. So potentially around 7 March, we will have 2 areas where we could look for cyclogenesis, leading to further development of a low pressure systems, while this one might be more in its decaying stage and this one more in its maturing stage. If we look a little bit at the precipitable water, you will see the structure of the low a little bit. You have the low here with the occlusions a little bit like this. The cold front will be somewhere situated here. There's like a small area of low pressure forming here, leading to a cold front here. There's a cold front here. And as this one digs southward, there's some interesting stuff going on. So if we look a little bit further, you will see as this trough digs a little bit southward, you can see a closed low forming here. And this closed low leads to a rather impressive structure in the low pressure system. As you can see here, we have a low here. There's a occlusion coming here. You can clearly see the frontal structure like this, and this one extending here. The warm conveyor belt is here. It branches off to the left, forming the occlusion here. And if we look a little bit further, it's rather impressive. So let's look a little bit further how that evolves, right? You can see the evolution of the low pressure system as we move a little bit further into time. Now, this is already 8 March, so weather does what weather wants. So this will probably change a little bit in the future, but it is something actually to keep an eye on. Also, if this low pressure area forms, there's like air rushing here from the Mediterranean over France, advecting north here. And if you look a little bit what that means on the temperature, right, where it is, temperature, right, you will see at the trough digs southward that it is indeed funneling all that warmer air from the south here into the southern of France. You can see that here in this region here. If we go a little bit further, or if we rock a little bit backwards and forward, you can clearly see that the milder temperatures are starting to invade Europe because of the digging of the low pressure area here. If you go a little bit back, you would see that complete motion here in the temperature chart, where you would see this low here maturing a little bit and digging a little bit deeper, right? There's a low area here. So if we go a little bit further, there's a low area now here where my detection system starts to catch up on that. And as we've already identified, there's a trough digging southward here, leading to a formation of a low pressure area here, leading to this flow, bringing milder temperatures here over Europe. What's also impressive to look at is the mean sea layer pressure anomaly. If you really look at it, this is a very deep low for this time of the year. The climatology that I use is the ERA 5, which is an ECMWF dataset. So what I've done is I mirrored the GFS forecast to the ERA 5 climatology data in the range of 1991 to 2020. And as you can see here, it's rather impressive low. We start with a higher than usual high pressure area here due to the system that we've already discussed. If we go further, that high pressure area diminishes. And because of the rather impressive trough digging south here, there's a build-up of a quite unseasonably high low, where this ranges in like minus 40 to minus 45 millibars than usual. So for this time of the year, it's quite an impressive system. If we check a little bit what that means when it comes to precipitation, I've created a simulated water vapor chart. I added the precipitation rate and the distinction of the precipitation type, along with the 500 millibar height contours. We have the same situation. There's like an IPV anomaly, as you can see here, in the water vapor, correlating well with the dip here in the 500 millibar levels. This one is moving east. If we rock this a little bit back and forward, you will see that happening right there. Right? And if you now go a little bit further, you would see the southward digging of this IPV anomaly here. Let's go a little bit further. If we go like this, you can clearly see that the IPV anomaly is digging further south. While it's digging further south, there's the formation of this low pressure area here. as we've already discussed. And you could clearly see on water vapor imagery that there is indeed cyclogenesis going on here, because if you look a little bit, this band here is the warm conveyor belt moving like this, and this low pressure area starts to build up the cyclogenesis process, where part of the warm conveyor belt is moving cyclonically around the low here, leading to the formation of a occlusion. If you go a little bit further, you will see that going on here. Man, I need to put the loop here so I can draw actually while this loop is happening. The warm conveyor belt here, moving cyclonically over here, and you can see this perfectly in the precipitation field here. Again, this trough ticks more southward, so if we go a little bit further, the warm conveyor belt is kicking up speed there, a little bit more south, right? Here. So while the trough is digging southward, the warm conveyor belt moves like here, leading to some rather impressive precipitation signals here going to affect Portugal and the Iberian Peninsula as a whole. You can clearly see that there's a branching off here from here to here, meaning that there's occlusion going to happen here. So there are, as we already identified, two areas of cyclogenesis, one here, leading to a whole from south to north advection of mid to high level air. Because of this milder air moving north in the temperature field over Europe, you will see milder and milder and milder temperatures going north. You can see that in the impulses here. You can really see the occlusion where I've drawn my hypothetical vectors. My hypothetical vectors. And from here on out, the low gradually starting to fill, because you can see the pressure building up here while the low is going to disappear a little bit. There's another low forming a little bit further here, but it's already 11 March, so let's not delve a little bit too deep into that aspect. So that's it for now, guys. Hope you liked the video. I will try to post a video in the very near future showing you what we might expect. All right. Okay. See you guys. Thank you for watching and listening. Bye.